Sorry about that. Sorry. Yeah. For those of you who are watching the recording now, I forgot to hit record, but essentially, we go in and import the asset pack that we started with. So import package, custom package, and then you select your package. It should take a few minutes, like a minute or so to load, and then you will end up with all the files we need for today's work. Okay. So you'll see that we still have nothing in our scene. That's because we have our sample scene loaded. So if we want to go into our scenes folder and go to our grapple, and that's where we have all the stuff set up that we need for our project. So we can break down the project real quick, what we have set up here, and then we can go into how to implement our grapple hook. So if we press play just to see what's going on, we'll see that we have our player character. It's pointing at the mouse. We can move around and it'll play a moving animation. And then we can have a camera that follows it. We can't do anything right now. We can't click to shoot out a grapple hook, but we can collide with the walls. And that's really what we have so far. We have a basic 2D movement. And we talked about, for those of you in EGaDS, we went over how to do 2D movement in a previous workshop, but I can go break down and what we have so far. It's really only 2 scripts. So yeah. So in our scene right now, we have our 5 different grapple boxes. I parented them under one big game object that's holding all 5 of these small boxes. And each of these boxes, the reason they're blue is they're saved as a prefab. So if you grab any game object over here and then you drag it down, you'll actually save it as some kind of pre-built object. Now, I don't really want to do that. I don't really want to do that, but if I wanted to, I would be able to just save different game objects as a pre-built set of game objects. So each one of these boxes, we have our sprite. You can replace this box with whatever you want, really. You can replace it with any image. It just renders that to the screen. And each one of these has a box collider, which we also mentioned that previously, but a box collider is just going to be some kind of wall or some kind of square that you can collide with as a player or any other entity. Yep, and then we have our player character, and similarly, the player character also has a collider on it. This one's going to be a circle collider. You can see it, it's green over here. And that's what's causing our player to collide with our walls. It has a circle collider that's interacting with that square collider on the box. And what we have here is a rigid body 2D. This is going to handle the physics of the player. And we're actually moving the player differently, which we'll go into in a bit. But this is how the player is moving, essentially. And here we have a line renderer. This is what I added previously just to, so we can work with, this is what's going to draw our grapple hook in general. So it's going to draw the rope for our grapple hook later. I have it deactivated over here. You can activate and deactivate certain components, and we'll get into that in a bit. And we have our player movement script that we'll look into when we're looking at the scripts. So this is going to be moving this character. So that 2D movement, up, down, left, right, that's handled by this player movement script. And we have our camera, and this is just a simple camera follow script. And it's just going to track the player and then just ease into it by linear interpolation onto the player's position. So we'll look into that when we're looking at the scripts too. So let's look at the scripts over here. So if you click into the scripts folder, you'll see that there are two little C# scripts over here, and these are just what's running the game so far. Scripts. Yeah. So this is just going to. Okay, let's start with the start. So in a Unity script, there is a start method and an update method. We went over this before, but start is going to initialize at the start when you hit that start, or if that object goes into scope. The update is going to be running every frame when when the game is running, every frame, these two lines will be called on this object. Fixed update, though, is also another special method within Unity, and this is going to happen every physics frame. Physics frames don't happen every frame. It's usually used for setting rigid body velocities or just making sure you're not updating the physics every frame, because that does make the game jittery. So that's where we're handling our movement. So starting up here, we have references to our rigid body. If you remember, that rigid body is this component over here. Yeah, that's going to handle the movement. So over here, when we're setting the rigid body velocity to our input and then multiplied by the speed float that we have up here, that's going to move the player in whatever input direction you have, which we're collecting every frame. So that's what's doing that. And the next part over here, down here, that's going to handle the rotation of the player. So it's a little bit of vector math, which I can explain real quick. So it's grabbing the direction by subtracting the camera's detection of the input of our mouse minus the position of the player. So I can do it real quick. I did a screenshot over here. So at this point, our player is facing this way over here, right? So what it's doing is we have we have where our cursor is over here, and then we have our player's position over here. Now, if you know anything about vectors, you can actually grab the direction by subtracting these 2 points over here, and then you'll get a direction vector that's pointing from here to here. So in this case, it will be negative something on the X and then positive something on the Y over here. So that's that subtraction over here. So this is our mouse input, and it's converting it into the world position. And then this is our player's position, and that's how it's calculating that direction. Now, you can break that direction down so you can get the angle that you need to set the rotation of that rigid body. So you're getting the arctangent of so you'll get the Y and the X over here, right? And then you'll get your angle over here. Now, it is offset by 90 over here, and that's only because our starting position over here is 90 degrees. If it were facing this way directly, then it would be, you wouldn't need to subtract that 90. But yeah, that's the only reason for that. Okay, so that's the player movement script in general. And the camera script, that's just going to follow the player. It's doing something called linear interpolation, which is just, you have a target position and current position, and then you're just moving there over time by this fraction over here. But that isn't really the scope of our project here. But that's just telling you a little bit of what's going on inside our project right now to get our just basic 2D movement going. Okay. So what do we want to do in this project? So we went over some of this. We can delete that. So as you can see from our previous slide over here, we want a way for our player to get from an initial position to our target position. And we want it to only work on walls and obstacles. And then we should have set range. We should be able to tweak the stats, and then we should probably shoot out the road. So this is where we can just look at our scene right now and just sort of visualize what we want to do. So as it said, we would want to shoot out our road, right? So we'll want some way, first of all, we'll probably want some way to know if our target exists. So we have a set range, right? And we want to know if there is a box to even shoot out the road. So we'll probably need some way to detect that. And that's something we can do. We already are able to get the direction that the player is facing in, from what I explained earlier. So what we can do is do some kind of ray cast over here. I'll do this in red. And then that's just going to detect at a certain distance. So let's say it's like this distance. And just do a ray cast in the direction the player is facing. And in this case, it finds this box over here. So then because it finds that, then it knows we can do some kind of start sequence for the rope and just shoot it out until it hits that spot that it finds over here. So how raycast work is it actually finds the first point that it finds applied in Unity. So if there were another box over here, it wouldn't shoot the rope all the way here. It would shoot it over here if we're setting the target to whatever it finds. So it would not find anything behind it. It would just find that first box over here. Okay. Yeah, so that's one way we can find it. So we'll probably want some kind of keybind to start that sequence. We can just bind it to our mouse click. So let's just create our script right now, just to get a starting point. So we can go to our player. We'll probably want our player to handle our grappling hook logic. So let's just add a component. Actually, we'll just add a script over here in the scripts. Create C# script. And we'll just call this grapple or something. Grapple. And it will take a while to rebuild the C# assembly. Okay, you'll see that Visual Studio finds it. So this is the basic template of our C# script in Unity. So I tend to like to say that it is private. It's just a little neater. If you leave that empty, it is private, but it just looks better to me. So what we can do to start is in our update, we'll probably want some kind of check if input dot get button down 0 get mouse button. And that's going to detect some kind of mouse click over here. We'll probably want some kind of state to say we are grappling, so we don't want is grappling, and we'll probably want to start that as false. Yep. And then we can just do that, not is grappling. So now, since this is starting as false, we can do a quick debug check. And when we run our game and then left click, we should get a response in our debug, just to make sure we are correctly checking if we are clicking down. That is an issue because we didn't attach our script to our player. So now that that's attached to it, it will actually run that script. Yep. So when we left click, you'll get a high over here. So we know that it is performing that check. And since grapple is always false, it will always pass that. Okay. So in this, we'll probably want some kind of start grappling sequence. This is just pseudocode. We're going to implement that later. Okay. Some other things we probably need, private line render. That's just going to be drawing our rope later on. And we'll probably want some kind of max distance, right? And we want to be able to set that in our player. So we can use something we talked about earlier in a previous workshop, serialized field. Anything with this modifier in front of it is going to be editable inside Unity. So we'll probably want private float max distance, and we can set that to 10. So now, if we look over here, yeah. So you can see that now we can change that to whatever we want when we're messing with our player's graphic. Awesome. And we can just initialize this equals the component and render it. So that's going to get the component that's on our player over here. Not the rigid body, the line render over here. Okay. And we're probably going to want some kind of target. So vector 2, target. And that's just going to be our target distance. So when we find something over here, when we find that point's going to be our target point that we set. So let's do our start graphing. So we can do our we can set a start graphing. And it's just going to be a void for now. So we can use the same method that we did over here, where we get the direction. So we're going to do vector 3 mouse range equals that, and then subtract it from our transform position. And that's just going to get not mouse direction. So it is the same method that we will use in our player movement over here to get the direction that we're facing in. The direction vector. Then what we can do is we do, well, GitHub Copilot already knows, but we're doing raycast hit 2D. And what this is doing is the physics 2D raycast is it's going to cast this ray over here to detect whatever collision over here. So at this point, it's going to find this collider over here. Yeah. So it takes in the starting point, which is the origin where the player is. So it's going to cast it out from here. It's going to go in our direction over here where we're facing. And it's actually going to use our max distance. So it's only going to check up to 10 units in unity. Okay. So we can just do an if this hit is dot collider is not equal to 10. So what that's going to do is it's going to check if what we hit over here has a collider. And if it does have a collider, let's just do our, and we'll actually need to call this start graphing. So we can do here. Let's see if that does anything. Okay. Let's see. I made a mistake here. It seems to be finding it on every single note. Let me just double check my notes. If they want to make it to this point, yeah. You are right. You are right. Yes. Okay. So that is one more thing. You're absolutely right. I completely forgot. So we do need to do some kind of layer mask onto the player. So player can be on default, but what we want to do is we want to look over here and we want to set some kind of layer mask. So let's do a grab layer over here. Thanks, by the way. I completely missed that. So we'll probably want to do some kind of layer mask over here. That's going to be our grab layer. And we'll probably want to serialize here. Okay. So now we'll go to our player over here. We'll want to set the layer over here to, I did not set one. So we can create one for these boxes. We can add a layer over here. Grab layer. Here you can name it whatever you want. And then when we can set all our boxes over here to that grab layer. Yeah. And we can set our thing to look for. Where's that one option? Is it down there? Should be. Should be able to, yeah, that grab layer. Okay, just need to. Okay, and then now we'll only look for sliders on that layer over there. So it won't do anything here, but it will find it there. Over there. So now I can find it within 10 units. It'll be able to find whatever box is there. So in this case, we clear this. If we're pointing this way, there's nothing. If we click, there's nothing. But if we face this box over here, we'll find that. We will hit that box, which is cool. Okay. So in this, once we do detect this box, we'll probably want to set our target to the hit point. So the target is hit that point. Then we can also set is grabbing is true over here. So indicate that we started the sequence of shooting out our grapple hook. We don't want to detect any more boxes when we click. So it won't activate a second time once it detects a box. Okay. And we'll want to set up our line render. So if we look at our player line render over here, we can take a look at it. So we can activate it just to take a look. And actually, there's a positions list over here that we can set to, for now, to size 2, so we can take a look. And if we were to move this out, you'll see that we have this rope over here. So it's going to go from 0.0 to 0.1. So our number 1 point is going to be 2.18, and then that's going to be our rope over here. So we're going to want to use this so we can start generating our rope and shooting it out. So we can set this back to 0, get rid of those elements, and then set it back to disable. And we can actually enable it over here. So you can enable components to, by doing that. Line renderer.enable, set it to true. And at the start, it's false. So that's just perfect, but we can make sure that it is false. So it's a false at the start. Okay. And we're going to probably want to set the position, and then probably want to set there to be 2 points at that point. Okay. And at this point, we're going to want to start our shoot grapple sequence. So that's going to be some kind of action that we're taking to shoot out this string over here. So for stuff that's done over time in Unity, you want to use something called a coroutine or an async method. In this case, we're going to be using a coroutine, so we can do a start coroutine over here, and we're just going to call it shoot grapple over here. So what a coroutine is over here, we can define it. Start grapple. So enumerator. This is us. C# thing. Shoot grapple. And then that's going to be our enumerator, which is also a coroutine. So in this, we're going to want to shoot out our rope over here. So we're going to want to first set up our positions. So dot position, set position. And then we're going to want to set our 0, because we have a 0 and a 1 over here. When we have we have a 0 index and a 1 index. So we're going to want to set the position of 0. And the starting point is going to be our transform dot position, right? And then the second one's going to be our target, which we set over here. Okay. So when we go, we can do, actually, we're probably going to want to do this over a period of time. So we can do a time. Just so we can control how fast we're shooting out this rope, and that can be really handy. And we'll just pass in like 5 seconds. Okay, so we can do float t, float less than time. Then you can add the time, delta time. And for those of you who attended previous workshops, you know delta time is the time in between, not float. Delta time is the time in between each frame. And then what we do here is yield return. And what this does inside an enumerator is it skips the frame. So it doesn't run anything else further down. It just skips the frame and then returns back to it on the next frame where it left off in this for loop over here. So in this case, it's going to, until the time elapses. Oh, 0. Yeah, so it's going to start from 0 until our elapsed time, and then it's just going to increment by however long each frame takes. So this is just a simple counter for going from our initial position to our final position. So we can set our new position. Actually, we'll just do our character to new position. And we can set our new position to something called a vector to dot. And that's going to be our starting position and our target position in our starting position and our final position in our set of positions from our start to our target. So we can do a transform dot position and then our target, and then we're going to do by the fraction of the time that's elapsed so far. So when we're like, for this case, we're at 5 seconds. When it's at 2.5 over here, then it's going to be half the distance over. So this is just going to go over in that period of time. Now, we're not doing anything with this new position, so let's set it. So we can set our line render, set position of 1 to our new position. And we can actually set our position 0 to our old position, which is our transform dot position. So even if we're moving, this will still update because this is setting it to our current position over here. So our rope will follow us even when we're moving at the moment. Okay. Now, at the end, we can just set it to our target, and it is all good. And at this point, let's just debug.log our little high statement, just to make sure we made it through. And see, let's just see what happens here. So now you'll see over 5 seconds, it's going to shoot out that thing, and it will print high. So right now, we can't really do anything with this. We just drew a line onto the screen. It doesn't really do anything. So we're going to want to call some kind of retract method that's going to pull us towards that box. But at this point, we made a spider web shoot. So it's all good. So this is the point where we're going to want to call some kind of sequence that retracts that graph. And for that, we can just do it over here in our update method where we set some kind of boolean to signal that we did shoot out our grapple successfully. But we can also just do another another coroutine. So let's just do that. We can do a retract. And in this case, we don't need to set any of these because the line render has already set our line. So we can call this remove stuff like that. We can set up an original position. And set that to the transfer position. And then we can use that to find. We can use that to find our new position. And the reason we're not using transform.position here is because our transform position is moving, because we're actually moving towards that target over there. So we sent this out, but we want to move ourselves over to that box. But we're using our own transform.position to calculate that. It's going to accelerate towards it, which we can do, but in this case, we want this time to represent the amount of time elapsed to get there. So in this case, we can just store that and then use that to calculate to our target. And our target doesn't change, so we can still use that. Retract that. So we can do do that call over here, and that's just going to call it and then set it over 5 seconds over here. All right. Let's just make sure that everything is okay. We did not set, we want to set our transform position to our new position over here. So we're actually moving ourselves. And then we can also set this. This all seems okay, except one, we probably want to do be our target. And then our 0 wants to be our transform position. Yeah. Okay. So let's see how this works for now. Okay. It's spinning out. I probably should have chosen 5 seconds. But yeah, now it's moving us towards the. Now there is an issue with this. That is, it doesn't actually fully reach it might not fully reach depending on how you set your glider to that position. So what we can do is we can just do a quick distance check over here. So if vector2, distance, transform position, and target is less than a certain threshold, we'll do 0.5 or something. Then we can just break from this and then be on our way. Thanks for coming. Oh, you're good. You're good. All right. And so if we check that, just to make sure everything works, I'll set this to 1 second just to test faster. But you can see now we have a working graphic, and you can see that there's the line render is still showing. That's because we did not disable it. So we can go ahead and do that. Line render dot enable is false. And we can also set is grappling to false too. That's our initial checker over here, if you remember. Just to make sure we can grapple again. So if we run our code, you'll see we can do that, spit out, and then we're all good to go. We'll do it again, spit out. Now, in our objective, we wanted this to be modular. Right now, it's not really modular. We're actually using magic numbers in our code over here. Hi, thanks for coming. So we'll probably want some kind of parameter over here. So we can do another serialized field. And we can do shoot speed, shoot time, better word for it, shoot time, and then we can set the default to 1. And we can do a retract time, which is let's set it to 1 by default. And then when we're calling our coroutines, we can pass in our shoot retract time over here, and then our shoot time over here. There are floats, yes. So if we look in our editor, you'll see that we have our default shoot and retract times. We can speed that up to 0.5, and then maybe we want to retract a little slower because the characters have it. Then we can go boom, boom, and then we can be on our way. And this works when we're moving too. And then we're all good. Everyone been following along? Okay. Yeah. I do have the final code as a package. If you want to check that out, I will send that out afterwards. But this is pretty much it. If you have any questions, let me know. But yeah, this is all I had planned for the Yeah. Mm-hmm. Yeah, so because we set of the way we set this up, we'll actually take that so long to get there, even if we're closer. So this isn't necessarily the best way to set it. We can set it up this way. I think it looks fine, but some people might prefer to set it based on speed. So there is that. We would be able to set something like that. Yeah, some other changes you could also make is right now it does nothing. There's no response when it's out of range, which isn't, some people don't like that. So what you could do is modify the coroutine to just, even if it's not available to fire out, maybe some kind of parameter for shooting a blank. If it shoots out to the max distance and then comes back, just to show that you did click, but it's just out of range. So there's different stuff you can change with this, but this is like a pretty basic way to do it based off of time. All right. Yeah, that's it. I'm gonna be sticking around, but yeah, that's all I have. Yeah. Oh yeah, sure. Um, was it the setting up or the in the code? Okay, yeah, yeah. So when you click on any game object, you can actually go into here and manually set whatever layer it's at. And if it doesn't exist there, you can click add layer, and you have it's a 32-bit, so you can set these layers individually if you want. And in this case, I used layer 6 to set up my grab layer. And for each of these boxes, you can set grab layer over there. And if you want to select them all, you can set them all together like that by that's shift click over here. Yes. So in the script, we have our grab layer over here that we set as a serialized field. So if we go to our player, you'll see that we can set it over here. Sometimes it doesn't, it pops off the screen, but if you click here, yeah, you see it's grab layers over there. And then when we're doing a raycast hit, you add grab layer as one of the parameters, and then we'll check for only that. For raycast, oh, did you do serialized field layer mask grab layer? If you want to show it to me. So did I go too fast? Wait, you can just, because like no one was talking, so I was just started going fast. Oh no, I'm sorry. So there's the grab. Oh yeah. Sorry.